This lesson is going to be on integration by partial fractions. This is an integration technique used throughout the Calculus BC course. I'm going to start off with an example because this technique does not require a specific formula. Now, as you can see, we are given an integration problem with the fraction 8x plus 1 over x squared minus x minus 6. Now, there's no other way we can solve this integral because using what we know, all we know is a u sub. We can't do a u because if we try using a u, we could try x squared minus x minus 6, but then we wouldn't get anything that we could substitute with, which would be, that would make it 2x minus 1. We can't substitute that for the 8x plus 1 over there. So that is why you have to learn this new technique on integration by partial fractions, where we're going to take this fraction and we're going to break it up into parts so that we can solve the integral. Now to start, I'm going to ignore the integral part of this problem right now and just focus on the fraction inside. So I'm going to bring it out right now, the 8x plus 1 over. Now we want to factor the bottom so that we can split it into two separate fractions. So if you have x squared minus x minus 6 and you factor that, you'll get x minus 3 and x plus 2. So we're going to take that and we're just going to put it right here, x minus 3 and then times x plus 2. Now we're going to set it equal to something. Now this is the part where we are going to separate this one fraction into two separate fractions with an x minus 3 and an x plus 2 in the denominators. So we are going to have a constant and a b constant in the numerators. Now the next step to this is going to be getting rid of this denominator right here, and it's going to lead us to an equation, and then we will split off into two separate methods that I will show you. So here we go. We need to multiply every single term by x minus 3 times x plus 2. So if I'm going to bring this down a bit right here and probably change color right here. Okay. So we have 8x plus 1 over x minus 3 and x times x plus 2. And then equals a over x minus 3 plus b over x plus 2. Now we need to get rid of this, so we're going to multiply every term by x minus 3 times x plus 2, multiply the entire term here, and then we're going to multiply this term as well, times x minus 3, x plus 2. Sorry, it's a little small here. Okay, and then we're going to also multiply this term times x minus 3 and x plus 2. So back over here, the whole thing cancels out with this denominator so that we got rid of that. And then look at this. You have x minus 3 and x minus 3, so the x minus 3's cancel out. Then over here, you'll have x plus 2 and x plus 2, so those will cancel out. And it just makes our job a little bit easier. So then our end result and our equation that we will work off of will become, sorry, marker's a little dead, 8x plus 1 equals a times x plus 2 plus b times x minus 3. That is the equation we're going to work on for the next few steps. Feel free to pause the video to make sure you have this down because I will erase it and continue. I'll give you a few more seconds and erase. Okay, so Now I'm going to show you two different methods that are used from this equation. Here I'm going to write it down once more. We'll have 8x plus 1 equals a, and then x plus 2 plus b times x minus 3. There, that is our equation there. And so I could erase this. Now there are two different methods to go about this, to solve for a and to solve for b, because we need to solve for those so that we can plug those into our split fractions for our original problem. Now here I am going to show you method number 1. Method number 1. Here we go. So first of all, method number 1, to solve for a and b. We're going to simply distribute these out right now. So we are going to have, here I'm going to switch, we are going to have 8x plus 1. We're going to distribute the a and distribute the b, okay? So of 8x plus 1 equals ax plus 2a plus bx minus 3b. That is us distributing it. That's what it should look like. And now we're going to take the like terms out of this equation, and we're going to create two separate equations out of it. So we have 8x, we have ax, and we have bx. So we're going to make an equation 8x equals ax plus bx. And then if we can take away all the x's, because we can divide everything by x. Divide everything by x, and all the x's go away, so you have 8 equals a plus b. And now we're going to make one more small equation out of this, which would be the other like terms, the 1, the 2a, and the negative 3b. Don't forget about the little negative right there. So it's going to be 1 equals 2a minus 3b. And then, yeah, that's our second equation. Now we can solve for a and solve for b using these two equations. Now after this, you can either go about using the process of elimination when you have a system of equations, or you can use substitution or any other method that you may know. I'm not going to do two different ways, but right now I'm just going to use a simple substitution. So I will solve for a in this equation, and I will have a equals 8 minus b. And then I'm going to plug this in to this equation and solve for b. So I'll have 1 equals 2 times 8 minus b minus 3b. And then I'll solve for b, and then b, after doing this, b will equal 3. And now I'm going to put this into this equation, put b into this equation, and I'll have a equals 5. And there you have it. You'll have b equals 3 and a equals 5 using method 1. And then we would plug those into our split fractions from the beginning. And now I'm about to show you method number 2. Feel free to pause the video so that you have this down, and then because I'm going to continue in a few seconds. Now I'm going to show you method number 2. Method number 2 seems to be the more preferred method for partial fractions, but personally I use either method, whichever comes to my head first. Method number 2, we are not going to distribute these. Instead, we're going to look for the zeros, the numbers that will make whatever's in those parentheses equal to 0. So in the first one, we'd set it equal to 0, so x plus 2 equals 0, and you'll get x equals negative 2. That'll make this 0. And so for the second one, we would have x minus 3 equals 0, so then our x would be 3. 3 minus 3 is equal to 0. Negative 2 plus 2 is equal to 0. So now that we established our zeros, we're going to split, we're going to use both of these to solve for A and solve for B individually. So our first one is going to be plugging negative 2 into all of the x's. So x equals negative 2. Here we go. 8 times negative 2 plus 1, I'm just plugging it in, equals A, and then negative 2 plus, negative 2 plus 2, which is equal to 0, and then plus B, and then negative 2 minus 3. We could just cancel this out because that'll just become 0. So we'll have negative 16 plus 1, which would be negative 15, equals negative 2 minus 3 is negative 5, so we'll have negative 5b, and then we get b is equal to 3. So then there we have b, same b as we got last time. So now we're going to solve for a. So we're going to plug in 3 into all of the x's as the same way we plugged in all of the 2's into the x's. So we'll have 8. Oops. I need to get a new marker. There we go. We'll have 8 times 3 plus 1 equals a times 3 plus 2. And then the b is 0, so we could just leave that out. So now we solve for a. We'll have 8 times 3, 24 plus 1 is 25. 25 is equal to 3 plus 2 is 5, 5a. Divide by 5 on both sides, we'll get a is equal to 5. That is exactly what we got for method number 1. This method does seem a little easier, but there are going to be some cases where we can't use this method. Go ahead and pause the video. I'm going to continue. So going back to our split fractions at the beginning, we have our a and our b. We had a equals 5 and our b equal to 3. So we're just going to put that here and here. So 5 and 3. There. That's simple. To split our fractions, that is our answer. And we are going to replace this, that is inside our integral, with this. So our original integral was the integral of 8x plus 1 over x squared minus x minus 6 dx. And now we are going to replace it with the integral of 5 over x minus 3 plus 3 over x plus 2 dx. Now we can take the integral of this. Before we couldn't, but now we can because we split it into two separate fractions. Now if you know your basic rules of integrals, you know that we can split this into two separate integrals, which would be the integral of 5 over x minus 3 plus, dx, plus the integral of 3 over x plus 2 dx. And then using our basic u subs, you have u equals x minus 3 and u equals x plus 2. Well, actually I'd have to use a different kind of u because they're two separate problems. So u1 equals x plus 2 here, and then eventually you'll end up with 5 times the natural log of the absolute value of x minus 3 plus 3 times the natural log of the absolute value of x plus 2 plus c. Sorry, my expression is messed up here, but I'm out of room. Alright, and that would be your answer. Let's do another example. So here I have the integral of x squared plus x minus 1 over x times x squared minus 1 dx. And so I'm going to separate, I'm going to ignore the integral part for now, and we're just going to look at the fraction like we did in the last example. X squared plus x minus 1 all over x times x squared minus 1 minus 1. Now you see here, we also need to factor out this one right here, the x squared minus 1, to make it simpler. So that we are now going to, we're planning on separating it into 3 fractions, so we'll have an a, b, and a c, and we'll be solving for all 3 of those. So right now we need to solve for the x squared minus 1. X squared minus 1, that would just be x plus 1 times x minus 1. So then we would have an x, we'd have a over just an x, then we'd have x minus 1, or x plus 1, and then x minus 1. We can put these in any order we want, because we'll get the same answer either way. But right now I'm just going to put them in the order that I have them. So that is our split fraction that we will be working with, and we'll be solving for a, b, and c. So as I did in the last example, we're going to multiply this denominator to every single term that we have. So if I multiply this to everything, if I multiply x and then x squared minus 1, I'll be left with, in the first term, I'll be left with, let's see, actually I'll just rewrite this. X squared plus x minus 1 will equal a times x minus 1 times x plus 1, and then plus b, and then we'll have x minus 1, and then x, and then plus c, see if I have room for this, and then times x plus 1, and then times x. Barely, I think I barely made it. Times x right there, that's an x. And then that'll be the equation that we're working with, unfortunately. And I will erase this and start on doing method 1. Here I just rewrote our equation, but I distributed each term and made them a little bit more simple and easier to work with. So now we have to make 3 separate equations so that we can solve for our a, our b, and our c. So we're going to distribute these out even further, and then we're going to combine like terms. So we'll have x squared plus x minus 1 equals ax squared minus a plus bx squared minus bx plus cx squared plus cx. So now we're going to look at the like terms, the x squared, ax squared, bx squared, and cx squared. Put those into one equation. So we have x squared equals ax squared plus bx squared plus cx squared. All the x squareds go away because you could divide everything by x squared, and you'll get 1 1 equals a plus b plus c. There you have it. So 1 equals a plus b plus c. And then that is our first equation that we will be working with. Our second equation will be the next term. So we'll have x, there's no x there, so we'll have negative bx, don't forget about the negative, and then cx. So it'll be x equals negative bx, and then plus cx. All the x's go away, so we'll have 1 equals negative b plus c, or c minus b, either or. Now that is going to be our second equation that we'll be working with to find a, b, and c. And now our third equation, we're going to look at this one and this one. It'll just be negative 1 equals negative a. That makes it easier for us because a just equals 1. Now we already have a, so then we could plug in a to each of these. Oh, we don't have an a here, so we can't plug in a here. But we can already plug a into here. So now we'll solve for b and for c. So I'll get my black marker again. We already know that a equals 1. And so we can take this equation right here and we could solve for c. So c equals 1 plus b. And then we take our 1 plus b and put it into this equation and take our 1 and put it into this equation. So we'd have 1 equals 1 plus... Actually, yeah, we would plug this in for c, not for b, but for c. So it would be, and then plus 1 plus b, right there. And we combine the 1's and combine the b's, we'll have 1 equals 2 plus 2b, and then subtract 2 on both sides, so we'll have negative 1 equals 2b, so b would equal negative 1/2. So there's our b, and we have our a. Now we just go back to this equation here and solve for our c. So we have 1 equals 1 minus 1/2 plus c. Let's solve for c. So we combine these and we get 3/2. 1 minus 1/2, sorry, is actually 1/2. So we have 1 equals 1/2 plus c. And then subtract 1/2 on both sides. So 1 minus 1/2 is 1/2. So c equals 1/2. So out of these now we have our c, our a, and our b. So now we can go back to our other equation from the other, from when I didn't erase it before, and plug those in, and then we could solve for our integral. Now continuing on, I erased everything, and I went back to our split fractions. So we had our a, b, and c, so I'll just put those in right now. Our a is 1, so that's just, the first term is 1 over x. Our b is negative 1/2, which right now I won't simplify it yet, but I'll put a 1/2 there. And then our c is 1/2, so I'll just put a 1/2 there for right now. So I could erase these, and then to simplify, we would have 1 over x minus 1 all over 2 times x plus 1. That 1/2 moves to the bottom if you know how to move the fractions when a fraction is divided by a fraction. And then plus 1 over 2 times x minus 1. And this is our new split fraction that we can perform an integral on. And this would be our integral problem, 1 over x minus 1 over 2, and then x plus 1, and then plus x 1 over 2, and then x minus 1 dx. Now that would be the new integral problem, and I used method 1. I haven't used method 2 on this one yet, but I trust that you guys can solve this integral because you could use a basic use of for the x plus 1 and an x minus 1, and then this of course is just the natural log of x, or the natural log of the absolute value of x. So that it concludes our lesson on integration by partial fractions, and thank you.